Today we'll look at a function f of x and g of x where the integral of a to b and a prime to b prime both exist, but the composition of both functions does not exist. So how is this even possible, right now? So we of course need that g maps inputs from a prime and b prime to a and b, because otherwise the inputs don't make sense and f just can go from a to b to anywhere. So first let's define what integration actually means, and for that let me clean up the board. Okay, so we'll use the epsilon delta definition to define what f of x is integrable means. So we get for all epsilon greater than 0. There exists two functions. Well, first of all, t0 and t1. I'll explain later what this means. We need that to, where to is bigger than f0, is bigger than t1, and from this should follow that the integral of, I don't know, the region of t1 minus t0 dx is less than epsilon. So what are t1 and t0? These are functions that are called step functions. For example, if you just have a function that is constant in some intervals, we call this a step functions. And for integration, we actually don't really care about what these bounds are, because we can always integrate them. They are constants. So in between these points, we can literally draw any point, and it doesn't really matter where they are. If you don't have this definition explicitly, then you can also prove, like if you, for example, said that this point is always excluded and the other one is included, you can also prove that these points in between don't really matter. So now that we know what integrable means, we have to figure out a function that is not integrable. So where the integral does not exist. So for example, one common function that is often used is f of x, which is defined as 0 if x is rational and 1 else. So if it is irrational, right? So I can't really draw this function because it's made up of infinitely many points. But it would look something like this. Here are infinitely many points, and here are also infinitely many points. And you can see, if we would try to figure out a function that is larger than this, than all points, then we need this function. This is the lowest bound we can get, right? So this would be to. And the smallest function that is below every point, we can only get t1. So that's a problem, right? Because we always have a certain room that is unreachable. So there exists an epsilon for, so let's say epsilon 1/2, which we cannot reach. We cannot reach this gap, right? So that means that f of x is not integrable. But now we need a composition of two functions such that the composition is not integrable. So how would we do this? So one thing you might have thought about is Thomae's function, which is a good guess. So let's define it really quick. So this is Thomae's function. It is 0 for all irrational points, and it is 1 over b if it can be written as a fraction of two integers, right? So of course this is not rigorous. For example, because we can write 3/6 is equal to 1/2. So will this output 1/6 or 1/2? We will always use the one that is in the least complex form. So this is Thomae's function. This is a lot of nice properties, but we just need integratableness. So we need a function that's lower than every point, and of course that's just x equals 0, right? This will be our t1. And now we just need an epsilon difference. And since we're starting from 0 to 1, our epsilon will just be a constant function. But now we have a problem, right? Because some points are above this function. So we need to show that we can get this epsilon such that this stays the same. It stays the same value in the integral, but it still is above every point. So what we need for this is that there are finitely many points above this line. So let's look at how many y values can be larger than epsilon. So we need, since the y value is 1 over b, we need 1 over b to be larger than epsilon. We know that for all epsilon greater than 0 there exists a n, which says that after all these n's, so after some natural number, all of the natural numbers, the irreciprocal, are smaller than epsilon, which is just obvious, and I think Archimedes' axiom or something. And we can use this to rewrite this as there exists a n such that all n smaller than this are bigger than epsilon. So we know that for this n, this holds true, that for all n smaller than n, 1 over n is bigger than epsilon. And since these n's are finite, there are finitely many reciprocals, so finitely many y values that are larger than epsilon. But there might be like 1/2 here, 1/3 here, and 1/3 here. So we need to include that. So then how many values can be reached? Well, we have, of course, that 0 is smaller than a over b, smaller than 1, because these are just our bounds. So then we get that 0 is smaller than a, smaller than b, but our n here is just the b values. It's 1 over b, right? And that means that our a is also bounded. So there are still finitely many points that are above this epsilon line. And since we know that there are finitely many points above this line, we can just use the step function definition to say, well, that's a step until this point, and then that's a step until this point, but this point can be higher than the original step. And we can do this with all of the finitely many points. Still, with the other definition, this trick still works, and you would have a half epsilon here, and then you would shrink the borders and everything. It still works, but with this definition it's easy, and you can see that we can get this bound arbitrarily low. So that means that the Thomae's function is integratable and has the value from 0 to 1 of 0. So now we just need a function that maps all these points that are exactly 0 still to 0, and every point that's above 0, well, to some constant, let's say 1. And gladly there is a really nice function. It's called, I think, the Signum function. And it maps 0 to 0 and every point larger than 0 to 1. And you might realize that this is a stepwise function. So this is integrable. And so that means that Signum of the Thomae's function is not integrable. So now again we have that Thomae's function of 0 to 1 is 0. It maps all points from 0 to 1 to an interval of 0 to 1, or 1/2. And the Signum function from 0 to 1 of x dx is equal to 1. But the composition of both of these functions does not exist. So we're done. By the way, why this does not exist, I proved it in the beginning. I didn't prove it, but it's the function where all rational points are 1 and then irrational points are 0. So this function does not have an integral. Thank you so much for watching. Please don't forget to subscribe. Also, you can watch another video about the catenoid, which is a minimal surface, where I derive which formula this is. And you could also watch a video about the arc length and some applications of this. Bye.